So for this first one, we're going to make our radical. 14 goes underneath. Remember, the denominator goes in the hook. So what's the denominator of our fraction? 3. So we're going to put that in the hook. And then our exponent goes on the outside. For question B, there's an invisible 2. If you don't see a number in the hook, it's because it's 2. And there's also a power of 1 on the outside. But what's important is that you understand is that 2, and then you make your parentheses. The only thing that goes inside of the parentheses is what's under the radical. So the 2 is not going to go inside, just an x. And it's to the power of 1/2. For our last one, we make our radical. 5x goes underneath. 2, that's your denominator, that goes in the hook. And it's raised to the power of 1. All right, go ahead, take out your note packet. We're doing just a few review questions. And again, like I said, we'll be finished. Tomorrow, you're going to get your review. On Monday, I'm checking that review for extra credit. I passed out homework 3 a long time ago. I think I passed, but it's over in that integrated thing. I think I passed it out on Tuesday. So I have a lot of extras over there though if you need one. All right, so go to page 19. In your note packet, so we got a word problem. It says, Kate is decorating a rectangular pavilion for a party and wants to string lights along the edge of the roof. 2 of the sides have a length of 13√5 and the other side has a length of 6√45. How many feet of lights will Kate need to decorate? So this is addition. So notice it says that we're using this number twice because there's 2 sides that are 13√5. So we're adding 13√5. So let me go ahead and draw a rectangle. I think that might be helpful. So we have 13√5 on 2 sides. And then on the other 2 sides, we have 6√45. And what this question is actually asking us to do is find the perimeter, which means that I'm adding all 4 sides together. So I'm just going to rewrite that so it's a little neater. So I have 13√5 plus 13√5 plus 6√45 plus 6√45. Okay. So we need to build a cake with the numbers underneath the square root. However, these 2 numbers are prime. So we don't need to build a cake for the 5s. We only need to build one for 45. So build your cake for 45. Let's go ahead and build that to the side. See how many layers it takes to get to a 1. Okay, so when we build our cake, how many layers did it take you to get to a 1? Show me with your fingers. How many layers did it take? 3. So divided by 3 first. 3 goes into 45 15 times. 3 goes into 15, 5. 5 goes into 5 one time. So I have a pair of 3s. So that means I already have a 6 in front. I'm adding a 3. And then that's going to be root 5. So these two sides are actually 18 root 5. So when I'm adding it together, they are all like terms, because they all have a 5 underneath the radical. So pick up your calculator and let's add these numbers in front. You're adding 13 plus 13 plus 18 plus 18. So take 13 plus 13 plus 18 plus 18. And what did you get, Cortez? 188. Anybody else get 188? Oh, that might be a little too big. Do that again. 62. Anybody get 62? 13 plus 13 plus 18 plus 18, 62. So my answer would be 62 square root of 5 feet. That's how much feet of lights she's going to need to go around the entire rectangle. Yes.
Why did you have to do the cake method?
So, because it wasn't simplified. 5 was already simplified. So, for example, what I mean is if I try to build a cake with 5, I don't have any pairs. But you always see, like, I just knew that that was a prime number, so I didn't need to build a cake for it. But 45 is not prime. It has to be a prime number underneath the radical, or a number that doesn't have a pair, I should say. It's not necessarily a prime number, but it's a number that doesn't have a pair. All right, I think we have another word problem here. All right, it says a business is adding a wheelchair ramp to their building. The 3 ramps will require 10 root 28, 13 root 7, and 4 root 112. How much concrete will be added to the 3 ramps? So what I need to add these numbers together. So I'm adding 10 root 28 plus 13 root 7 plus 4 root 112. Now I know that this number is already prime. I don't need to build a cake. But I do need to build cakes for these 2 numbers. So build your cake for 28. I'm going to do this off to the side so I have some space. All right, so build your cake for 28. And then build your cake for 112. Okay, so when I build the cake for 28, first we're going to divide it by 2. So 2 goes into 28 14 times. 2 goes into 14 17. 7 times. 7 goes into 7 one time. So that means that I have a pair of 2s that's going to come out. So that will be 10 times 2 root 7, which is 20 root 7. And then the second term is already simplified, so we're not changing that one at all. And now let's do our 112. All right, so 2 goes into 112. I think that's 56. And then 2 goes into 56, 28. And then 2 goes into 28, 14. And then 2 goes into 14, 7. 7 goes into 1 time. So I have 2 pairs that get to come out. So that means I already had a 4, but I'm multiplying it by 2 twice now. So pick up your calculator, multiply 4 times 2 times 2. So 4 times 2 is 8. 8 times 2 is 16. So we got 16 root 7. Are these 3 like terms? Can we add them together? Yep. So pick up your calculator and add 20 plus 13 plus 16. $41? $49? Anybody else get 49? I don't have a calculator. I'm trusting y'all. We got 49. All right, so our answer would be 49 root 7. Does your notes have an A, B, C, and D choice, or just A and B? Okay, so mine's just, so what was the answer? C. Okay, so the answer would be C. All right, so we're actually just about done. Yesterday we talked about adding, and today we're going to talk about multiplying. When you multiply, we're going to start by multiplying the numbers in front. So the numbers in front would be 5 times 4, and 5 times 4 is 20. And then you're going to multiply your square roots. So 3 times 6 is 18. Go ahead and build a cake with the 18. All right, so when I build my cake with 18, I start off with 2. 2 goes into 18 9 times. 3 goes into 9 3 times. 3 goes into 3 1 time. So I have a pair. I have a pair of 3s that can come out. That pair of 3s is going to come out with the 20. There's already a 20 in the front, so I'm multiplying that 20 by 3. And now what's the number underneath the radical? 2. Go ahead, pick up your calculator, multiply 20 times 3, and you should get 60 root 2. And that would be your final answer. All right, last one, and then we're going to do some practice. A couple more questions, and then we'll be finished. So let's go ahead and take the 3 times negative 9. So we're multiplying the numbers in front. 3 times negative 9 is negative 27. And then 10 times 6 is 60. Build a cake with 60. All right, when I build my cake, with the 60, I start off by dividing it by 2. 2 goes into 60 30 times. 2 goes into 30 15 times. 3 goes into 15 5 times. 5 goes into 5 1 time. So I have a pair that can come out. So along with the 27, I also now have a 2. And then underneath the square root, I have 5 and a 3. So 5 times 3. So pick up your calculators, multiply these two numbers in the front. So negative 27 times 2 would be negative 54. And then when I multiply what's underneath the radical, that would be 15. And that is your final answer. So we got a couple practice questions on the back, and we are finished with Module 10. So let's go ahead and work through these 4 questions together. So we're actually just going to do, let's do 1 and 4. Let's do 1 and 4. So let's build your cake. So you got plenty of space. Build a cake with 24. Build a cake with 54. So let's start off with number 1. Build a cake with 24. Build a cake with 54. So when I build my cake with 24, all right, I got 4 layers. So I already have, let me go ahead and take off this so I have more space. So we already had a 3 in the front. So I already had a 3 in the front, so that 3 is still there. But now I'm adding to that a pair of what? What do I have a pair of? Pair of 2s. That can go in the front with the 3. And then underneath the square root, I have a 3 times 2, which is 6. So that becomes 6 root 6. All right, now let's build our cake with 54. So we divide that by 2, that gives us 27. Divide that by 3, by 3, by 3. So we already have a 2, but I'm adding to that a pair of 3. So that's 2 times 3. And then underneath the square root is a 3 times 2, which is a 6. So that's also 6 root 6. So when I add them together, I'm adding the 6's in front, and my final answer would be 12 square root of 6. All right, let's look at number 4. So for question 4, there is an invisible 1 in front of that root 3, so I'm multiplying 2 times 1, which is 2. And then I'm multiplying 12 times 3, which is 36. Build your cake with 36. So when I build my cake with 36, 2 goes into 36 18 times, 2 goes into 18 9 times, 3 goes into 9 3 times, and 3 goes into 3 1 time. So notice that in this example, I have 2 pairs. This also happened in question 2 on your homework. Sometimes you don't have anything left out. So what I have is I have 2, and I'm multiplying that by 3 times 2. I have nothing underneath the square root. So I'm multiplying the 2 that was already there by my pair of 3s and by my pairs of 2s. So when you put this in your calculator, 2 times 3 times 2. What is 2 times 3 times 2? It's just a 12, so we don't have a radical. I am giving extra credit for homework 3 today. Use the rest of this class period to work on homework 3. I'm not going to be here tomorrow. The sub is going to give you a study guide. Work on the study guide tomorrow during class, and Monday you get extra credit.